Good morning, everybody, and welcome back to the Infrastructure for Sustainable Fuels session in partnership with Future Cleantech Architects. In the Kamaha Universal at the moment is Project Facilitation in Fragile Countries. This session is going to be discussing infrastructure considerations needed to produce and bring sustainable aviation and shipping fuels to the operations of maritime port and airports, and highlighting examples of successful projects. So first of all, I'd like to invite Peter Schniering to the stage, who's the founder and CEO of Future Cleantech Architects. He's going to deliver a scene-setting presentation on the key challenges in decarbonising shipping and aviation. He'll also be moderating the panel session, but we'll get to that later.
Thank you very much, Catherine, for the kind introduction, and good morning, good day, everybody. Welcome, and we appreciate you find the time to join us here. There'll be more people pouring in since one of the sessions was running over time. Yes, we want to talk about the infrastructure challenges in shipping and aviation today, which is a big topic, as you can imagine. So we have carefully prepared the panel discussion and some scene-setting presentations. I will just do a 5-minute opening to give you a big bird-eye perspective, so high-level perspective on the sector, and then the IRENA expert, Arno van der Bos, will continue diving a little deeper on the pathways. So without further ado, or maybe I should add, Future Cleantech Architects is a climate innovation think tank, so we only tackle hard-to-abate sector challenges in our daily work, and shipping and aviation, as you can imagine, are some of these challenges. So we'd like to start with a Slido, and the Slido that you're about to be seeing, or that you can answer now, is what percentage do you believe of international shipping cargo by weight is used just to transport fossil fuels? Is it 4%, is it 14%, or is it 40%? Please cast your vote, and we will see what the solution is. It's heavily debated, I know. It's been in many fora, but it would be great if you give us your view. And 14% catching up. So it's almost, 60-40. It's picking up. So 40% seems to be defending its lead, 50-50. You're a very undecided audience, which is great. We might have some controversy on this later. So it's almost draw. It's almost the same result. Let me solve it. It's indeed 40%, 40. So an extremely high share of global maritime shipping by weight is caused by shipping fossil fuels. And without further ado, let's dive a little into shipping. What does that mean? What does this sector actually represent if we look at the transition, if we look at sort of turning to a hopefully net zero economy at some point? So you have seen the solution, it's 40%. This comes again. Here's the first slide I actually wanted to show, which is how big is the problem? What are we actually talking about when we talk shipping? And we've created this overview for you. You can also see it on the fact sheets we've brought and the documentation for this session. If we look at the energy-related emissions of global shipping, it represents about 2%. This is just carbon dioxide, though. There are non-CO2 effects as well as NOx that also contribute to global warming. Just to give you a feeling, also if we compare to aviation later, we are talking about almost 1 gigaton of carbon dioxide emissions per year caused by shipping alone, out of 8.1 for the entire transport sector. That's what we want you to take away. Now, how big is that if you compare, say, to a country? We're in Bonn, so we thought, let's compare it to Germany. Germany's total emissions, and it's about 1.3 times the emissions of Germany. It's just caused by shipping globally. Just this figure for you to take away. Now, we want to talk the transition today and the infrastructure challenges, and for that, we should have a quick look at where we are. And we've tried to visualize for you where we are. So on your left, you see the ships currently in operation, and we've tried to visualize by turning them gray or green to what extent they're already powered by sustainable fuels. And as of now, we are talking about 2% by number of ships that are being powered by what, it's a question of definition, of course, but biodiesel or test phases in methanol and other fuels that would be considered or generally be accepted as sustainable. It's 2% of the number of ships, and it's about 7% of the tonnage that's currently being shipped across oceans. It's powered by the common definition of alternative fuels. Now, if we look at the ships in order book as of 2024, you can see that the share is significantly larger. But if we look at the duration, at the life cycle of ships later, you can see that it's really an urgent question to speed this up if we want to get to the necessary fleet by 2050 that you can see on your right. Why is this the case? Why do we need to accelerate? One of the reasons is the operational lifespan. You can see this here, and I'm taking this away already. It's similar in aviation, of course. Ships produced today or finished today will be on the oceans for decades. So there are options, as we will discuss with the bright panel later, on blending fuels, on repowering these ships, but it's costly. And assets that are once in the water usually need to pay off and will be written off over a longer time. So much for shipping. Please try to remember these figures as we move on to aviation. And for aviation, we have another short Slido for you. I'm excited to see how divided you are on this. What percentage of the world's population has never boarded a plane? Is it 8%? Is it 48% of the global population as of today? Or is it 80%? I suppose you are all frequent flyers, so you can, of course, count yourselves out. But the background to the question is, of course, the rapidly growing segment of first-time flyers of parts of the world, not just parts of the world, but also parts of the populations that want to fly and have never flown. Okay, clear lead by now for 80% and minding the time. I'm taking this away already. You are right. The majority is right. About 80% of the world has never boarded a plane. Now, how big is the problem? Remember the shipping slide from before yet? We're talking about 2.5% of CO2 energy-related emissions caused by aviation, about 1 gigaton. But there's an important difference here, because the non-CO2 effects, and this is still under scientific observation right now. There's a lot of studies going on this, but the non-CO2 effects are significant in aviation, such as contrails. The formation of contrails and the avoidance of contrails is in a different dimension of contributing to climate change than the non-CO2 effects in shipping. We have a similar challenge when it comes to running out of time, because also the lifespan of airplanes is 2.5 decades, sometimes longer. So we have different opportunities, as we'll discuss in the panel later, with drop-in fuels, of course, in aviation than we have in shipping. But it's still another factor that urges us to move quickly with a rapidly growing market for aviation globally. Coming almost to an end, and I'm hoping this animation will work. You can see it on one of the fact sheets as well. We wanted to visualize how far you can go, as of current knowledge, with the various technologies to decarbonize flying. And here you have all-electric airplanes. You can see them here. It zooms in. That would take you to about 500 kilometers and no longer, though we really believe in the innovation potential of CATL and other companies that are driving battery innovations massively. Then let's look at hydrogen. How far would a hydrogen plane go? Here we have about 4,000 kilometers with huge infrastructure challenges, though. We'll discuss it later. And then finally, if we want to go the long-haul type of flights, I don't know whether I need to click or this starts automatically. Let me see. No. Sorry. So usually, imagine the fourth plane flying all the way from Mexico City over to the Middle East to, more than 10,000 kilometers, and that would be possible with sustainable aviation fuels. So that's a drop-in kind of method. There's the biofuel way, and there's the electric way. And this leads me over to all this is available on our website if you need it later. I'm not moving this forward. Let me see what's going wrong. Arno, the floor is yours. Let me introduce to you Arno van den Bos. He's analyst green hydrogen energy at IRENA. He's been also orchestrating most of this panel. So please give him a warm applause to dive a little deeper.
Thank you very much, Peter, and good morning, everyone. So I think Peter sketched the size or the scale of the challenge. I'll try to dive a little bit into some scenarios or how does IRENA look at this. What I'm showing you here is a slide that has a lot of information. It comes from our report on hard-to-abate sectors, so decarbonizing hard-to-abate sectors. Today we'll focus on shipping and aviation, but in the report you can find more. And what we're seeing here is we have essentially 4 essential strategies. The first one has to do with obviously improving energy efficiency. You don't have to decarbonize the energy you don't use. Second, we have electrification, and we can discuss this a bit later. And so the size of the circles shows the importance of this strategy in the particular sector, and whether the circle is full or not tells us how mature these strategies are or the technologies are. The third strategy goes through biomass and biofuels in this case. So this is a very important one for shipping and aviation, both. And last but not least, we have e-fuels that are based on hydrogen. So we make hydrogen from electricity. We could call them hydrogen-based fuels, but we call them e-fuels because they're made from renewable electricity initially. And for some of the sectors, there's a component of carbon capture, which might have a small role in shipping, but it's relatively minor. And so looking at our world energy transition outlook models from the past years, so we can look at the total energy demand by the shipping sector by 2050, and we see that the total demand goes down. This is both because of energy efficiency improvements and because of the point that Peter just made, is that some of the demand for shipping will not exactly evaporate, but will significantly diminish if other sectors do their job in decarbonizing properly, right? The 40% of what has to be moved around the seas will have to be substituted, and a lot of it will disappear. So that leaves us with still a very large demand, and the question is, what fuels will supply this? And so there's a lot of debates here, and IRENA scenario contemplates for a large amount of e-ammonia. So that's an e-fuel made from hydrogen and nitrogen, so not carbon containing, which is its major advantage. It is toxic, and it does require major investments and capacity building in the fueling infrastructure, in the bunkering infrastructure. Then we have, of course, biofuels, advanced biofuels, which can be made from residues or from lignocellulosic fuels. We see today a big shift to LNG. So I think if you look at the order books today, they reflect a strong move to LNG, liquid natural gas, and that could be substituted. And so the question is, well, it will happen with biogas, right? So the same technology, but different sources. And then there's even a small part for electrification. And the other e-fuel is e-methanol. So methanol can be made both directly from biomass or from hydrogen and electricity. So we can discuss later if we all agree with this. There's a lot of pros and cons for each option. One issue I'll highlight is that methanol requires a sustainable source of carbon. I'll come back to that. But of course, unfortunately, all these energy sources are very expensive. So the ranges are broad here. There's still uncertainty. It depends on the scale, depends on where you do this and on your resources and when. But essentially, we see clearly that biofuels are more expensive than, actually that's not shown here, but actually the lower lines, the ones that go at the bottom, show very low sulfur fuel oil. So this is the heavy fuel oil that ships burn, and that is unfortunately very cheap and dirty. And so biofuels are about 2 or 3 times more expensive, and then the e-fuels are even an order of magnitude above that, right? So ammonia, we expect ammonia to be used, today it's used for many other sectors, so there is an ammonia industry, but it's gray ammonia, and so we'll see that from 2030 30 and 40, we expect a growth in green ammonia, and then ammonia will also start filling roles for energy and feedstocks in new industries that it doesn't do today. And methanol, this is quite a complex slide, but essentially I mentioned you can make methanol directly from biomass, or you can make it from green hydrogen, and then you need to add a source of renewable carbon. And today, this renewable carbon mostly comes from biogenic carbon, which is the residue of different biomass processing. And some projects are contemplating doing this from direct air capture, which is unfortunately very expensive. Okay, so the e-fuel projects around the world all want to use biogenic carbon, and what we did here with my colleague Karen is quickly see what is the potential demand and what is the potential supply. And the main message here is that biogenic carbon is a scarce resource, and we need strategies for getting access to this and prioritize it, right? So biogenic CO2 might actually have a carbon footprint once you start pumping and moving it around. And even though it might be available at these biomass processing plants, it might not be available always for e-fuels. Okay, very quickly, aviation, and we can discuss this more in the panel, but of course the fuel discussion is similar, except ammonia is not an option and methanol isn't neither, so we need e-kerosene for the E side and biofuels for the kerosene side. This is from a fairly old report, but it shows kind of the roles that airports can have in the whole energy transition. So they can be a hub for electricity and for fuels, and we can discuss this perhaps a little bit later. And this is kind of filling a little bit of the gap of this 40% being moved by shipping. We believe that a large part of hydrogen will move around the world in the form of ammonia and of methanol. And so this will require some of the shipping capacity, but not all of it. And of course, this has major infrastructure implications. I'll leave you with some publications we've done on the subject that you can look up and download the slides later on, but we can discuss some of these issues further during the panel. So that was it for me.
Thank you. And could I ask, sorry, Zhang Chang to come up to the stage? She's Chief Engineer for the Hydrogen Energy Technology Department of the Huaneng Clean Energy Research Institute.
Okay. Good day, everyone. It's a pleasure to speak here. I'd like to talk about China's status and trends of green hydrogen fuels. Previously, we have introduced sustainable fuels or e-fuels. I think hydrogen-based fuels account for a great part of the sustainable fuels. In China, the transportation sector accounts for over 10% of the total carbon emissions. So, in hard to electrify sectors such as aviation and shipping, the e-fuels such as ammonia, methanol, and SAF have a vital role in the carbon reduction. Chinese government have proposed numerous encouraging facilities in e-fuels. For example, the dual carbon goals set carbon peaking and neutralizing goals poison sustainable fuels as key to energy transportation. The 14th five-year plan for aviation prioritized biofuel, green hydrogen, and other non-fossil fuels. Here is an estimation of all those fields in the future. We can see all of them will have a great improvement in 2020 and 2050. Ammonia is mainly applied in industrial sector, while methanol will experience explosive growth in transportation sector. Both of them, as well as SAF, bring up demand for green hydrogen. For green hydrogen alone, it has vital roles in various sectors, especially in power. Driven by the policies and future demands, there has been a lot of projects in China. Here are some of the some examples. Those projects make good experiences about technical development and industrial collaboration. Among those, we can see that the green hydrogen supply is a crucial issue for the industry. As a main source material, the stable supply of green hydrogen has an important role in the cost of the fuels, as well as the green attribute of the fuels, which affects their price. For hydrogen, there are a capacity of about 120,000 tons per year of hydrogen production by the end of last year. And more projects are being planned and applied. As for the development of hydrogen production, the key bottleneck is the cost. We need to bring up the energy efficiency, thus to reduce the need for power consumption, and make good coupling between hydrogen and electricity, thus to get access to low-cost power, uphold the green attribute of the hydrogen, as well as the fuels. So as one of the power source companies of China, Huaneng had done extensive work in hydrogen production. Here is the layout of the study in our institute. One focus of our work is the technology of green hydrogen production, from key materials to equipment. The other focus is the demonstration of hydrogen industry chain, including hydrogen electricity coupling and hydrogen application in various sectors. So we have produced the first electrolyzer over 1,000 nanometers per hour in China. And we have developed the dynamic controller for unstable hydrogen production to improve the electrolyzer design and operation control continuously. As for the projects, planning, design, and optimization software for large-scale wind, solar, hydrogen integration projects are developed with the goal of maximizing IRR, or electricity consumption ratio. Okay. All in all, we think with the energy strategy of China, e-fuels has a bright future in Chinese industry. And the integration with renewable energy is the key point to be solved in this industry. And the key focus for future development, I think, is for the cost reduction and the green certification. Okay, that's all. Looking forward to discuss with you further. Thank you.
Thank you so much. Now I'd like to invite Peter to come back up to the stage because he'll be moderating our panel discussion this morning.
Thank you so much, Catherine. Okay, so this is a complex topic, as you know, and we're seeing the speakers here for today, and I'd like to ask them on stage, and I'd like to give you a warm applause. I'll tell you why. It has to be specifically warm, because, for example, our previous speaker, Zhang Chang, arrived this morning at 5 a.m. at Frankfurt Airport. Pierpaolo, our experts from the European Transport and Energy Research Center, arrived at midnight last night from Paris. So please give all of them a warm applause, and I'll tell you who they are. So maybe we had the request that we sit in the order as they are placed on stage. So the first who would take the chair, her chair, is, you can all come on stage. Sorry, people are hesitating. So we have Arno van den Bos, whom you've met already. We have Ralph-Uwe Dietrich, who is the research group leader on techno-economic assessments at the German Aerospace Center, Deutsches Zentrum für Luft- und Raumfahrt. Many of you will know this research center. Pierpaolo Cazzola, who is director at the European Transport and Energy Research Center. You've already, then we've Santiago Haya-Leiva, who didn't have such a long way because could walk over theoretically from Bonn. He's international cooperation officer at the European Aviation Safety Agency, or European Union Aviation Safety Agency. And again, we welcome to stage Zhang Chang, whose presentation you've just heard. So, okay, final applause. I'll take my seat and we'll kick off with the moderation. All right, welcome everybody. In the preparations we've taken, and we've had a couple of calls and we've had a couple of discussions, we thought this is so complex that our objective is, or my objective is, to explain it to you, to get the main messages across and the deep dive segments these experts are working on, like you were a group of 10-year-olds. Okay? That's the level of ambition here, in very clear terms, and still dive deep enough, of course. So my first question would be, let's start with shipping maybe. And I would like to ask the first question to Pierpaolo, since Pierpaolo has been working on this for a long time. Maybe you can sketch in a sentence or two before you answer what your work entails or what you usually do on, say, an average week or so. But in particular, if you could give us an overview from your perspective, what are the infrastructure challenges? We've seen the high-level challenges for shipping. Where's the infrastructure challenge if we talk about these solution pathways?
Thank you, Peter. So I'm with the European Transport and Energy Research Center, affiliated with the University of California and Institute of Transportation Studies in Davis. And what I do is I do research on transport energy, clean energy, sustainable mobility. And working along with colleagues in California that I've been taking the lead, I would say, globally in promoting clean solutions for this. Okay, going to your question, I think in the scenario that was shown by Arno, have seen sizable shares of ammonia and methanol as potential fuels for low carbon shipping. There are also sizable shares of biofuels, and in particular, ammonia and methanol require separate storage, transport, and distribution facilities, which are important in terms of cost and investments, requirements in ports, and potentially also coming with competitiveness challenges, because ports that, for example, rely on ammonia may have access to a lower e-fuel as opposed to ports relying on e-methanol, and that means that they may attract more traffic. Other ports may lose traffic. Ports that actually work on e-diesel, which is smaller in shares, for example, secondary ports, may be in a position of disadvantage. Biofuels also play a very significant roles in terms of competing on costs, being potentially lower costs than the e-fuels we're talking about. So how do you actually sustain investment in a separate distribution, transport, and storage infrastructure while your competitor biofuels actually doesn't need that additional investment costs? So there's a bunch of topics that we can get into, but yeah, that's in high level, I think, charts out a little bit of the challenges.
Since not everybody's working on ports and shipping fuels all day here in the audience, can you give an example? If you look 10 years ahead and you think, or maybe 20 years ahead, and you think of, we've gone a part of this transformation already, what could be challenges? Maybe you can give an example on ammonia, for example. Is this something where you could sketch a scenario? Where could infrastructure challenges come from there?
Well, I'll give you an example on ammonia, which came from a conversation from somebody from the shipping sector, the International Chamber of Shipping. There are examples of ports that are interested in developing capacity to refuel ammonia and handle ammonia as a fuel. Imagine a port in the Nordic area, and if you have an urban port, you may have an exposure to risk related with safety and handling of ammonia close to an urban environment. So what I'm considering is basically using the opposite side of the fjord to have an ammonia
relocating
terminal.
The port.
Exactly. Which is something that comes with significant impacts on the port activities, the transportation system that needs to serve that port, and also the reutilization of the area that is what is in the current port. So all this kind of additional infrastructure to storage, distribution, and transport of ammonia, all these investments come on the top of that. And ultimately, that port may end up leveraging the possibility of having capacity to refuel ammonia to attract low-carbon maritime traffic at the detriment of other ports that do not have that capacity. So these are just concrete examples of potential local impacts that normally are not really well covered in terms of assessing these high-level scenarios, what could be the implications of such a transition.
Thank you. So we take from this one, there's competing solutions to some extent, and there's possibly a risk of technological lock-in. The second thing we would love you to take away is, if we look at ammonia, urban ports, that can be a difficult combination. If I may ask Arno because you've just given this overview, listening to what Pierpaolo's saying, what's your thoughts on this? Where do you see high-level challenges? Let's stay in shipping for now.
So I think we've seen that most of the emission reductions have to come from producing these fuels, right? So the availability of these fuels is a big challenge. How do we get enough financial investment decisions on the projects? We see a little bit of a chicken and egg in the situation where the developers on one side say, oh, there's not enough demand, and on the demand side we say, oh, there's not enough projects to actually buy from. So I think that's really in the production side. in moving the infrastructure around. Beyond what Pierpaolo mentioned, I think there will be some level of port specialization, right? So many ports will not be able to host both ammonia and methanol, and so they will have to make decisions. So that's a sort of strategic a challenge on the infrastructure. There's the whole certification part, but we can get to that. It's also very relevant for aviation, but it brings some coordination issues and streamlining there. And I mentioned, I referred to the CO2 challenge. If we want to have all the carbon containing, so except for ammonia, but methanol, kerosene, e-diesel, etc., will require enough renewable carbon. And so where are we going to get this from? The EU started to think about this, but many regions haven't even started that conversation. In many parts, they're still pumping around fossil CO2 for enhanced oil extraction, right? So that conversation really needs to move forward on many levels.
Thank you so much. And if you were to summarize this just in the headlines, what would be your top 2 or 3 headlines as of the infrastructure challenges? So I understand it would certainly be certification or just a ramp up of the production, correct? Producing the fuels, the source of the carbon. Anything else?
So the ramp up is really, I think, the key. How do you get these investments flowing, right? And so for that, we need the demand. So we have, I think, on the policy side, and Pierpaolo can maybe agree or disagree with me, but I think we've seen some increasing clarity on the policy side for demand increasing, but it might not be enough. So I think we need to see some additional demand from maybe private players, maybe large groups like DHL, which are already doing it, and Amazon, or alliances that form to create larger groups and volumes that can actually absorb more easily some of the premiums, because the premiums are really high, and the major question is how can you absorb those, right? And so I think there's a lot that needs to be done there. Governments can do public procurement, for example, to say, well, maybe our civil servants, when they fly around the world, will cover a part of or entirety of the fuel premium, so that they can fly or ship stuff around with green fuels. There's a digitalization there aspect that can help in efficiencies. What else did we? Well, I have more on the wish list, but maybe we can keep it for.
We'll get to that later. Great. If we take a look, if we look at the situation in China, Zhang Chang, for a second, maybe you've given this very comprehensive and visible overview of the current ramp up and the opportunities in hydrogen and its derivatives in China. If you look at shipping in particular, do you see this picking up enough speed? So do you think it's moving? Not maybe just in China, maybe also beyond Chinese borders at the right speed, or what is needed to be even faster in pushing fuels for shipping?
I think in the sector of shipping, to make the green transition, the use of green hydrogen is a necessity. So what you must concern first, I think it is the economics. For example, in a port like in the north of China or the east north of China, you must first you have to figure out the conditions such as the accessible renewable energies, the land that is affordable, and so on. And then you have to make decisions about some important route. Maybe you should you should transit the clean power to your port, or you should transport hydrogen or e-fuels to the port. That brings other questions, maybe about the instrument. Because if you want to transit the power, you should make the wire lines. And that brings the the possibility or the cost of the instruction. The same comes to the hydrogen pipeline or hydrogen transition. You have to consider the cost, the distance, the density of energy when the fuel is transported from one place to the other. Also, you can consider if you should produce the e-fuels on site and use it immediately. That benefits from the fact that you don't have to bring large storage tanks, but the license of the production station is an issue. No matter which choice you make, I think which choice you make, the key technical problem remains the cost of your e-fuels. That depends on the cost of your hydrogen.
Hydrogen, yeah. Thank you very much.
Thank you.
Now, we've been discussing with this perspective also the ramp up of fuels. We need to ramp up fuels and we need to make them competitive somehow. And if they're not competitive to the fossil alternative, there has to be a regime, there has to be some kind of mechanism in place that makes consumers, that makes governments, that makes the other actors adopt them nonetheless and ramp it up. So I would like to move to the production of fuels for aviation now, because we've got two people on this panel who do this all day. They deal with the safety of aviation and they deal with the production of the fuels and the techno-economic assessments around that. So obviously that's Santiago and Ralph-Uwe. And I'd like to start with you, Santiago, if I may. Your work is global, basically. Even though you have a short way here to IRENA Innovation Week from a location site, because you're located in Bonn, you're working in Africa a lot. You've been telling me about a project, I think it was in Kenya, where there is a refinery or there's a large facility, and it's a completely different story, convincing stakeholders, working with stakeholders to ramp up production there. Can you share some aspects of your work on sustainable aviation fuels production, certification, especially if we look at developing countries as well?
Thank you. Well, thank you very much for the invitation, having the opportunity. I think it's the first time EASA is participating in IRENA's event. And indeed, I think we will be more and more often, I think, with our role in sustainable aviation fuels will create that opportunity. So EASA, as it was mentioned, is certifying, is the responsible organization to certify the aviation products, so aircraft and engines and some others. And that is not only safety, but also environmental protection requirements. So you expect the colleagues very much into the standards and making sure that those products fulfill those standards. My role is bringing or supporting states also adopting international standards, in this case for sustainable aviation fuel. So the project you were mentioning is supporting 14 African states in the uptake or the scale-up of sustainable aviation fuels, which of course it first has to start with producing. You mentioned the challenges related to infrastructure. Obviously, when we go for a value chain, all pieces of infrastructure will be identified there. However, it's important to start tapping on the existing infrastructure. And this is something you were referring to Kenya, where, for example, existing refineries and moving them from brownfield to greenfield, and the possibility of repurposing those refineries or the infrastructure that are associated to that. And this is an enormous reduction of the capex of such production. And this is, for example, what we are supporting together with other partners. Indeed, GIZ and also some colleagues from the Netherlands are supporting these projects and are looking at what is the techno-economic analysis, what are the, let's say, the way to make a production project for sustainable aviation fuel, in this case coming from HEFA process, and I think we will go more in detail on those pathways, to make them viable. And viable means that in the next 20, 25 years that the plant will operate will give return of investment. So, and this is very important to start using the existing infrastructure.
Thank you very much. And you've brought us a slide showing the value chain, also to explain the challenges or the difficulties. And I think I need to click that. And I left it over here to run. Oh, somebody can do that maybe. Let me see. Sorry, we're jumping now. This is Ralph-Uwe's, but since Santiago started this, let me show you this one first.
Yeah.
Can you please share a thought on this, especially when it comes to the infrastructure challenges along this way?
Yeah, indeed, this is very kind of a high-level definition of a value chain for sustainable aviation fuels. There are many pathways, different pathways to produce, and pathways means combination of feedstock and technology, and obviously the associated industrial processes behind, but also including all the logistic chain that is put in place in order to bring from the feedstock to the final fuel into the aircraft. So all these pieces from feedstock collection, processing, treatment, all these elements have to be either created or tapping into existing value chains or logistic chains to reduce the cost. And that means that there are certain countries or certain locations which are more advantageous. And this is obviously the first area of analysis, is where these production projects can be set, taking advantage of existing capabilities, infrastructure, and also access to market. I think it was in the previous panel, there was some reference all related to hydrogen, but there were some references to the policy that is enabling market either in the UK or in the EU. And this is very attractive. And of course, that is a condition that will be fundamental for that. I will not go obviously on the value chain.
Thank you.
I will kill the panel. But also maybe even on the enablers is these gray boxes that you have below. There are organizations or type of actors that will make an essential role in making it happen. So governments with policies or investors or the buyers of these environmental attributes that can be monetarized. And here again, there might be policies, there might be self-commitments from organizations that will be an essential element as well to create the viability of those projects.
And if I may ask you to specify, looking at the infrastructure again, in this big picture, and you've pointed out the stakeholders we need, where do you see the largest challenges, top 2 or 3 challenges for infrastructure here?
That very much depends on the pathway. I mean, it's very much dependent on the pathway. If we look at, for example, something that is already existing that could be co-processing, so using a bio-crude coming from biomass, injecting that into an existing fossil fuel refinery, that will be minor, so to say. Obviously, there are some needs to make properly the treatment of the bio-crude and so on, but the value chain, the logistics and everything is almost there. What will be remaining will be the impact on the certification, ensuring that it's sustainable and is an aviation fuel. On the other extreme would be, for example, power to liquid, where this infrastructure does not exist and therefore requires a significant investment. So, I mean, maybe not giving you a straight answer, I see, but certainly depending on the pathway, and this is one of the areas that will require deeper analysis for the specific locations or the specific intention of different countries or organizations to start producing, they will need to identify what is their profile, what are the potential, and where they need to focus on.
One more?
Maybe I put it in more positive words. There is, when it goes to sustainable aviation fuel, and I think that is part of the rationale that you mentioned, this is a drop-in solution. It means that as a fuel, it fulfills all the conditions, all the chemical properties and related to safety, and therefore it can be used in the existing value chain. So all the airport facilities, obviously, that will be maybe depending on how it's being supplied. They might be requiring some blending facilities or additional tanks, or that's very specific to the location. But the aircraft, all the tanks, everything would be as if will be an aviation fuel.
Thank you. we're taking this as a takeaway, and we'd like to dive a little deeper with Ralph-Uwe into two production pathways. Before, though, I would like to ask Pierpaolo one more time, because you hearing what Santiago is describing from Kenya and other African countries, similar challenges across the world, of course. You first gave us your view on on shipping. Can you confirm this from your work? What other maybe challenges do you see for the aviation bit? And then we'll look at Ralph-Uwe's examples.
Okay, so one thing that strikes me is that we're talking about two sectors that need fuels. And one, aviation sector, has strongly opted for drop-in options, which is basically something that changes very little in the chemical properties of the existing fuels. There are pros and cons. You basically need to adapt renewables to petroleum-based kind of value chain, which means you may actually incur in higher costs if you actually move the petroleum value chain towards renewables. But there are also positive sides, because you basically have like advantages in terms of dealing with infrastructure costs that you don't need to face. And while in the other sector, in the case of shipping, there's a lot of interest in these alternative energy carriers, which require a different infrastructure. There's one in aviation, which is hydrogen itself, but it's, as you showed, primarily for short haul, primarily for relatively small volumes. So challenges on that, on the infrastructure, are significant. But what strikes me is really this different approach. I'm not sure let's say the drop-in option will not be relevant for shipping, and I think in the case of aviation, there will need to be an evolution towards some renewable fuel options which are not necessarily as homogeneously fit into the petroleum-based value chain. And I think there is work that is going in that direction, and I hope we'll see more of that.
Thank you so much. I see a hand raised. Santiago, quick shout in.
Yeah, no, indeed. I think it's a very valid point. Maybe for clarification, it's not that aviation is opting only for drop-in solutions. That is the timeline in order to bring new technology certified under the safety standards and then replacing the whole, let's say, fleet of aircraft. It's very lengthy. And there is work already going on. And obviously it's the transition, and this is the main. And the last, very, very quick, is all pathways are necessary. So I was mentioning the advantage of those that are kind of ready or half ready, but it's absolutely necessary to start preparing for those others that are much more complex, but will bring higher environmental values.
I don't know whether somebody's painting these beautiful summary pictures again, but should somebody be here, all pathways are necessary is a sentence I would love to see on that. Thank you very much. Ralph-Uwe, we come to you now. If I may briefly ask you to describe, first of all, what you're doing. What is this techno-economic analysis assessment you are doing? And then walk us through the production pathways for two types of aviation fuels.
Okay, thank you very much. Thank you for the kind invitation. I'm a chemical engineer. And as a chemical engineer, I'm trained, let's say, to optimize the flow sheet of my process. And with that, I can calculate efficiencies. And there's a pretty standard in a chemical engineering how to do any cost estimation. That is pretty rough. That is only the cost, the basic design. What already is sufficient in the chemical industry to decide, okay, that is a promising pathway we could invest. So in this pre-investment decision, so this is what where the science can work in, okay? And within the biofuels or sustainable aviation fuels, comes another dimension into that, and that is calculating sustainability. How green is a fuel? How green is a fuel? So, yeah, this is what we are doing. This is a group of 8 people is doing that, somewhat automating that we can really go into each of these different options. So, yeah, this is our daily doing.
Well understood.
Good.
And you've brought us a nice example. I'm just showing the first slide. Please explain what you've been doing there, or what's the key essence of this analysis.
This shows you one option of doing sustainable aviation fuel. But before I go a little bit deeper into that, we are talking about infrastructure. And the task of the infrastructure for the aviation fuels is connecting the source and the sink. The source is some crude oil tanker or crude oil pipeline, goes to a refinery, goes into the tanks on the airport, and then goes into the airplane. So, and this, let's say, infrastructure is established over decades and is evolving every day. Because if you go into the airplane, it's a construction site because it gets expanded every day. So, yeah, so that's why the source is somewhat known currently. They know even the quality of each crude oil and each tanker, and they can even adjust the refinery to do that the best way. So, and the source is known, but it's kind of evolving because the demand is rising. And in this, let's say, pre-optimized, let's say, pathway with all the constraints that do that. It's about reliability. It's about safety. It's about cost. It's about getting each of these partners getting their fair share of that. That is all established. And now, come the European Commission says, okay, this is what you do, and from now on, you will add a blending mandate of renewable fuel into that. And this causes a problem, an infrastructure problem if the source gets changed.
Mm-hmm. And if we could go into a specific example, if we may, can we come to that? Maybe
this is one example.
Yeah.
If we now change the feedstock, and the feedstock for one route that's called HEFA, hydroester fatty acid, you all cooking probably with olive oils. The Asian people are pretty familiar with soya oils. So these oily agricultural pathway can be used as well, or even let's say fatty fats, animal fats. Also, there's a bunch of biological oils and fats that can be used.
That can be used to produce the HEFA method type of aviation fuel.
And we know exactly how to do that. We know to do that with the fats. We don't know how to do that with rapeseed. We know how to do this with palm oil, whatsoever. So, and what I draw here now is where the problem lies. So if we look at the European map, where can we get these oily, fatty feedstocks from? So, and the point is that the source for this infrastructure get unsecure now. You have multiple options, and I only draw here that there are 4 or 5 different options. They placed Italy on the used cooking oil because they are cooking a lot with these olive oils, and if you collect all these olive oils, you can make a bunch of SAF out of that. So this is all what it should say. The uncertainty, what is the amount of feedstock, at what place, and how to build a plant on that. So this is what this picture should show, and all the obstacles that are related to that.
Understood. Now looping in Pierpaolo and Arno, and who else wants to contribute for a second, and then we look at the second example. What infrastructure, say, immediate challenge, if we look 10, 15 years, 20 years ahead, does that result in? Would you confirm that? What's your view on this? What does this, like, the change of the source, or the change of the geographic particularities depending on the production route? What kind of consequences does that have for us, not just in Europe, but as a global community in transition, so to say, for aviation fuels?
No, so generally speaking, I think the biosources are limited, of course, and then the definition of how much do we have or how much bioresources do we have depends on how you define sustainable. Sometimes some people even say the more sustainable, the more you have, but that depends on how you produce the production system. So that's a big question. I think recycled oils are a limited resource. We need to use it, but there's also competing uses, right? If we're going to import this from highly agricultural productive countries, we need to make sure that you engage as a buyer with those governances in those places. And so I think the trend in some countries like Germany and the US is to kind of reduce that engagement, and I would say make sure you don't disengage from that. But that's really on the availability of the supply, which is relevant for both aviation and for shipping. So I think those are the main challenges for those bioresources. If it enters the part about the infrastructure, but then there's a sustainability, which is the sort of soft underlying sustainability infrastructure layer.
First Pierpaolo and then back to Ralph.
First, sorry, I cannot help myself, but I doubt we use any olive oil in Italy to produce fuels. Normally that's used directly, and we don't fry stuff. We use cheaper oils for frying like everyone else. But I think a lot of the sources of the HEFA in Italy are actually imported oils. But anyway, what I want to say is that I'm not sure that the multiplicity of the possible feedstocks for HEFA is such an infrastructural challenge compared with others that we're talking about, like ammonia as a fuel, hydrogen as an energy carrier. So I think there are challenges, but they can be overcome basically in industrial complexes that handle more multiple feedstocks. The same logic can be applied to like only sourcing crude for a refinery from one particular supplier. Yes, then major events happen globally and refineries adapt, and it's not a tragedy. So I would say, I think that we're talking about two different orders of magnitudes in terms of infrastructural implications, in my understanding at least. I do see relevance, but I think there are other infrastructural challenges here, especially with the deeper transition that seems to weigh more, in my view.
If I may ask, Ralph, thank you both, and Ralph-Uwe, if you were to summarize, same as your colleagues have done, looking at aviation, what would be your top 2 or 3 infrastructure challenges?
I mean, what he already said, yes, you can do that. You can collect some feedstock and do that. But this is totally new for the refinery because they are not used to that. They are buying the tanker on the Mediterranean Sea or something. So, and now they need to have a multi-year contract getting this feedstock in the same quality year over year. And this is actually a challenge. So, and then it comes on top of that, if every European refinery invests in a HEFA plant, they are competing against each other. There will be a market drive over that they are stealing the feedstock one from each other, and we don't get anywhere. So because this feedstock is limited. So even if every refinery wants to make its business case, there is a market movement that actually nobody can really predict. Yeah? So one refinery cannot predict, do they get a better contract or so, kind of thing? And then they're competing on the feedstock side, and then they are competing on the product side because the blending mandate has to be fulfilled, and it will be fulfilled by the cheapest one, of course. And who gets the cheapest feedstock and the cheapest price for its fuel? That will be the economic challenge. I doubt that there is any technical challenge remaining. It's only the economics and the economics of each refinery and the market as a whole.
Thank you. I think it's a good point, and I think I'd like to open this next question up to all of you with one important question that concerns aviation the same way it does shipping. What kind of, because as we've heard from Ralph-Uwe, the devil's in the details. The devil's in orchestrating a market so we don't send perverted effects in a way that one is torpedoing the other, or that the carbon is just leaked or pushed out to another sector, appears elsewhere. What kind of market can there be for such international businesses as aviation and shipping? What kind of regime do you think can be realistic, can be achieved? We've seen some recent developments with IMO and other organizations working on it, but if I may pick your brains on what you believe minding these challenges are the most likely options. Whoever wants. Santiago.
So, first of all, I think there must be clear global standards, and that will certainly facilitate and avoiding either carbon leakages or having different considerations about the life cycle of the fuels. On on that, at least in aviation, it's quite, there is a push to go in that direction. So the International Civil Aviation Organization, together with all the states, are defining those standards, and then they are being implemented. There is also the ambition.
Short question, maybe you can summarize briefly. How far are we on these standards? I suppose some know, but can you summarize how far do you think is the process of the international community?
So if we are talking about the sustainability, for example, of the feedstock and then of the fuel, the final fuel, the core CA-label fuel, as it's called in the aviation sector, it is already there. So there are already standards to assess the sustainability of feedstock and then of the whole value chain, to end up with a certificate, a sustainability certificate or certification that reflects the environmental attributes of that fuel.
Thank you. Other comments on this? Pierpaolo and then Ralph-Uwe.
I want to say a couple of things. So on this sustainability certification, which is true, exists and is generally done by third parties, because bodies like ICAO or even a commission do not do the certification themselves. There are challenges, and they emerged quite clearly recently with basically volumes of palm oil meal effluent certified, which exceed what can ever be produced. And so I don't think we have sorted all the problems there, and there's work to do. On other things that have happened that I think are relevant for what you just asked, obviously the IMO decision taken recently, which needs to be finalized in October, is probably a very relevant one. I think it's a compromise that brings in interesting dynamics, the creation of a fund to actually finance the production of low carbon fuel, potentially other things. There are big questions about how that fund will work. But there is an interesting framing with the regulatory requirement and pricing mechanism, basically, that helps accelerating.
So generally positive.
I see generally positive, but there are questions with the fund in particular that need to be sorted out. And one more thing in aviation is, aviation policy is based on, I would say, the long-term aspirational goal. It's still an aspirational goal as far as I understand. Moving more into, let's say, a regulatory framework binding similar to IMO would really be helpful, I think, to essentially achieve progress. That's maybe a high-level thought on this that I think is worth bringing up.
Ralph-Uwe.
Yeah, I would say there are two factions here. Is the glass half full or half empty? So I'm more on the side of half empty, because what I see is there's a global general agreement. We need this. We need this global unification of this certification. But how is it done? The debate starts. Even Europe is somewhat on the forefront with this Refuel EU Aviation, with this RED II. There are some laws. What is sustainable and how to calculate is misleading, is wrong, is not really pushing the right direction in the regulation. So then we have the ICAO that is even weaker, but is with the intention to invite more participants to get to that later. So that's why I would say we are still on the stage. Yes, we need that. Well, we need to get it done. And we have then even the internal resistance in the aviation itself, and this is the certification process. If I have a new feedstock now, I need another 10 years to get this certification to any turbine, and it's tested and it's certified, and every vendor has signed it or so. That makes it even more complicated. So the regulation needs to be simplified, streamlined, and need to exactly reflect what is the environmental benefit we want to get and how we prove that.
I think another nice sentence for the summary picture, the regulation needs to be simplified and streamlined.
Yeah.
Arno, I wanted to ask you anyways, but go ahead.
No, so I agree. I think that the challenges that are trying to be addressed are really complex, right? And so I think it's difficult to make simple regulation to address really complex process. I think the EU has done a pretty good job at coming up with, I mean, it's considered globally the most advanced framework. It is complex. It's sometimes the difficulty is in actually having people understand what it means. Sometimes it counts with different scenarios and different contexts. They try to include all of that. And so for some people think they need to know about everything when really they only need to know one piece of the puzzle. But I do think it's important to mention that this is really key for keeping the legitimacy of the business going, right? Because if there's a lot amount of risks that if things are not done well, then people don't want it anymore, and then you basically take an option off the table that we really need. So I think there's things that can be simplified. I mean, I've got plenty of ideas of how to improve it. We can discuss those later. So it's not that it's perfect, but I think it's important to recognize. And other countries are actually looking at what's happening in the EU to either copy or get inspired and do some similar things there. So
thank you. Zhang Chang, I see you holding the mic. Anything you want to add from your perspective?
In a global view, taking hydrogen instrument and technology, for example, I think the main point of global collaboration is the certification, the global-wide certification. For this, we should strengthen the communication between nation and nation, so the good products can be used worldwide. So it would not happen that some, for example, some products from, for example, China, when it was shipped to Europe, there are some components that are not accepted. So the cost of the company would be raised, and that would be bad for the collaboration and co-development. That's all. Thank you.
Thank you very much. I would like to do a little exercise with all of you, which is we're sketching a scenario for a future almost decarbonized, at least to some extent, much less carbon-intensive sector for shipping and for aviation. And you co-build it, or you agree or disagree with me. Let's start with shipping, and please everybody add your comments. So we're a couple of decades from now. I don't want to say the year, but yeah, it makes it hard. Let's say 15 years from now, 20. Short-term shipping, short distance shipping is electrified as far as we can. Riverine, ferries. To what distance can we take all electric shipping?
I think it's reasonable to expect that short-distance shipping, ferries, as you said, potentially also some of the waterborne shipping can electrify. I think all port operations can be shifted towards electricity. In Europe, the alternative fuel infrastructure regulation goes precisely in that direction. To which distance? I think it depends on the cost of the batteries, cost-benefit analysis, but there have been, I don't want to give a figure, but I think it's a significant share of short-distance shipping can be electrified. What cannot be electrified is intercontinental transport, like very long distance. There are options with battery swapping, which are being considered.
Containerized.
Yes.
Yeah.
So even that could become part of the solution. There are logistical challenges, but well, that's, I think, the boundary of the limit of what can be done with electricity in shipping.
Okay. So then we have the transcontinental shipping. And here we have methanol, we have ammonia. So will we see ammonia predominantly for long-distance shipping between certain ports? Will the toxicity concerns have been overcome? So would you consider this a part of this future world in 20 years, maybe? Arno?
Well, I think if you look at the fuels we use today, they're also not very healthy, right? So there are toxicity challenges that we have managed to address in using kerosene and or the heavy fuel oils for shipping and diesel. So I think if we can do it for those, the challenges are a bit different. I mean, ammonia evaporates and gets you the fume, so you do need to manage that. What needs to happen there? So I had some interesting discussions with people from the Lloyd's Register Decarbonization Hub, and they said they're thinking about how to design, for example, the ships so that the challenges basically not disappear, but that you don't have to. So you both need to do capacity building of the people who operate it and who do the bunkering and the storage, but you can also, by doing better design, reduce the risks. So there's a lot of I think things that can be done there that are a bit underestimated. And towards the question of long distance, I think ammonia is a great fuel in the sense that it's probably the most economic way of shipping around e-fuels around the world. So that's kind of our baseline, and it doesn't depend on the carbon, which makes it a lot more complex. So I think that's, and I see a number of companies like Fortescue and a bunch of larger developers going that way. There's no guarantee that this will happen, right? So there's still a lot that needs to be done. But so yeah, that will be my bet.
Short comment, please.
Okay, this is a concept that didn't come through so far, and I think it's worth bringing up, which is the idea of green shipping corridors. So, I mean, if this happens, it will happen first through that. So basically ports, pairs of ports, liners operating between ports.
To and fro.
To and from, that will guarantee offtakes and in a regulated market, because we're talking about more expensive fuels, and so in that kind of framing, or with sustainable fuel buyers alliances, voluntary alliances, similar to what has been also mentioned for aviation. So the same concept exists in shipping. So that's probably what can lead to the materialization of part of the solution. There's one more thing I want to say on ammonia. It's carbon-free, but it can lead to N2O emissions, and N2O is greenhouse gas. So ammonia needs to be aligned also in terms of abating NOx and N2O emissions with proper environmental regulatory frameworks. It's not simply a solution per se, and then also ammonia today is produced mostly from fossil gas. So we're talking about a massive transition also on the upstream
Production
part,
side, upstream part. Thank you very much. Zhang Chang, anything you want to add on the future picture of shipping fuels, in addition to anything on the methanol or on other derivatives? Do you see any other contenders there?
The similarity is with the aviation, that the big contribution of the CO2 comes from the large distance. So, and that's why all these small ferries are nice. But if you start with your 38 gigatons, so then actually it's questionable if you even need to care. You have this hydrogen airplane with 500 kilometers. Actually, it's not getting there far, so it's minor, and then it's more risky. But even that, if that is only, let's say, 20% of the CO2 emissions of the aviation, we don't need to bother. If we need to invest, if we need to invest billions of now, then go after the big picture.
One in 20 flight creates 38% of emissions. That's true, but still we need to care for all pathways. Would you like to add something, Zhang Chang, on this?
Thank you. I got ammonia, so I'd like to add that in China, we are considering add ammonia into coal for power generation in
storage.
Yeah. So the CO2 will be reduced. Also, it brings the problem of NOx. So we are working on this. Actually, the guidance of the government policies is not less than 10% of ammonia should be added. Ammonia and something green like ammonia should be added to the power generation machine using carbon. I think this is also a way to use ammonia. So in China, we think ammonia would be used in industrial sector, power sector.
In a multi-purpose way. Thank you. Let's move to the aviation world in 20 years, Santiago, and then Ralph-Uwe. Sketch us this vision. So how do we fly in 20 years?
So certainly if you are solo pilot, kind of a recreational, you will be flying in electric aircraft. So small ones for sure, that will be. As Uwe said, is very modest contribution to the decarbonization, but it's a way also of proving the technology and scaling the technology later. Obviously, all aircraft will be flying with a significant amount of sustainable aviation fuels in their tanks. All this fuel will come from almost all pathways that we have now, and probably, hopefully, in new ones that will come along in the future, like methanol to jet or any other that may come. Your airport will be fully green. I mean, your airport will have a very, very low carbon footprint.
All electrified?
Correct. And, well, obviously, the first steps of the regional electric aircraft, for example, will be starting, and there will be much progress on the research for hydrogen.
Mm-hmm. Ralph-Uwe, something to add?
I mean, the SRF will win where the green carbon is the cheapest and the hydrogen is the cheapest.
Mm-hmm.
That's how to combine that. Chemical engineers can do that. So that's why I not somewhat disagree. We have every pathway. No, there will be winners and losers. So, and one winner is this HEFA kerosene because it's the cheapest. It's already oily, right? I have not much to do as a chemical engineer. So, and that's why whatever we can do, we are using that. And if we, let's say, need, less biodiesel from rapeseed, there might be even more resources to come. But it might be even the opposite direction, that the competition gets harder and we struggle to get the feedstock. This is somehow open. And then I had this second slide that I might only talk about. If you use biomass, woody biomass, that is pretty green. You don't need even fertilizer for that. And you add that hydrogen that you get from renewables. So then you get already in the range of 30 million tons. In Europe alone would be a huge way forward. So that's why there are some leaders in that pathways. So, and they are regionally different. And maybe really, if there is enough ethanol available, that might be the winner in Brazil or somewhere else. So I'm only concentrated in Europe, and we shouldn't use our sugar or so to make kerosene of that. So it's not working. Yeah.
Thank you. Now, those I know you have another comment. You get the floor. Those of you who have attended previous events like this, or of ours, Future Cleantech Festival, so know towards the end of the session, and I'm just getting the sign, we have probably 4 minutes left only, and I promise to let you go for lunch on time. At the end of each session, the Cleantech ferry lands. And the ferry is giving each part of the panel 3 wishes, maximum. Can also be 2. What will need to happen most urgently in the sector you're working in to get to this world that we've just been sketching? So to make sure that by 2045, 2050 and on, we decarbonize to the maximum extent. Zhang Chang, you may start. What would be your wishes? What would make your work easier? What would help accelerate this process?
What make it to be accelerated? That
transition, yes.
That the green transition. Thank you. I think the development of electrolytic technology helps a lot. For example, now we have new electrolyzers, meaning ammonia exchange membrane electrolyzers. China already have thousands of kilowatts capacity machines. It helps reduce the energy consumption of hydrogen, and the flexible modulation of the power according to the flexible power input.
Thank you very much. Two wishes. Santiago.
Maybe very quickly. So probably starting with partnerships, and partnerships not only between different type of organizations, but also across sectors. I think that is quite important. And then policy development that is really crafted to ensure or to empower the production and the use of these sustainable fuels.
Partnerships and customized policy development. Thank you. Pierpaolo.
Okay, my wishes are policy related.
Shoot them out.
We get the right policy mechanisms to trigger the change. That includes carbon pricing, and it includes a combination of regulatory requirements and carbon pricing with these incentive mechanisms that use revenues from carbon pricing to stimulate technological progress and hence also lead to more final investment decisions on the supply of the fuels and the purchase of vessels that actually use low carbon energy carriers.
So more FIDs.
Aviation or shipping. It's
more final investment decisions fast, right?
More policy progress and more final investment decisions.
Thank you very much. Ralph-Uwe.
I mean, I'm the technical guy, so that's why I would say all the technical issues can be solved. So that's why my wishes are, as we already told, regulation. Streamline the regulation, force the regulation, make it so strong that nobody can sneak out or so, would be number one. And then internationalize. So that would be number one wish, right? Number two wish is boosting the investment, both in renewable energy and even in these SRF plants. And if the oil industry is resistant, I would even push to take away their profits and invest instead of them, just to make it work. We are always in the risk to delay the 2030. So because they think, okay, it might not be at harsh or so yeah. So that would be really number two, to make this investment wave boosting. Yeah. And number three wish, it's totally out of the box. It's totally out of the box. This is to the audience here, especially to the ones from the global south. Help Europe to end the war against Ukraine. Because if we get rid of this burden, we can help Africa, we can help Asia even more to commonly develop that. But to do so, we need to get rid of this burden. So that would be my third wish.
Okay, that was sort of a political side comment here. And also we have the impression in all the international sort of fora we take that there's a strong drive coming from, of course, Africa and Southeast Asia and other countries. Not sure to what extent. Sometimes I think Europe is still needed there, but Europe needs to be part of the overall solution, I think, jointly developing this. Thank you. Now, when I discussed with Arno, of course, before we started, you had 6 wishes on your list, I think. Try to boil them. No, you can mention them all. I think they had only 2.
No, I'll very quickly, I think the first point I would say is don't underestimate battery technologies because the densities have really improved majorly. It will not make a huge dent into the consumption but on the short term, but on the long term, I think you can look at hybrid options that actually work. And second, I would say learn from each other, and I'll mention a couple of examples that have worked well that I'd like to see scale. One is a partnership that we've done with ICAO, so the International Civil Aviation Organization. So we've expanding our ETAF platform, which is the Energy Transition Accelerator Financing. We're now building a module, also with support of EASA, so that's also how EASA has worked with IRENA. So the platform itself is already leveraged $4 billion for renewable energy projects. Some of that will now start flowing to e-fuels and biofuels for aviation specifically. And the last example I wanted to mention is what ports can do in both, and I think this would also work at airports, is that the fees that they charge to the people who use them, or the companies, so when Maersk pays a fee when it goes to the port of Rotterdam, now the ports themselves can also provide incentives, and this is already happening, where they say a group of ship operators buy their fuels together, and they say if you do this from green fuels, we give you a discount or even waive this fee. So this is actually a way of making start investing flowing to these projects, which is really what needs to happen to address this big e-fuels.
What a final spurt, what a loaded ferry that must be. Big applause for this panel, please. And thank you very much for your attention. That's it.
Thank you, Peter.
Thank you very much to all. Ooh. Sorry. I'm shorter than I thought I was. Thank you very much. That was a fascinating session. Really, really interesting. It is time for us to break. If you would be back here at 1:30, we've got a fabulous session. We've got the closing ceremony. We've got reporting back from the 2 different streams. We have a panel discussion on structural change and innovation for sustainable development. And all in all, it should be a great afternoon. So we'll see you at 1:30. Thank you.